Hello, my name is Daryl Da Silva, and today we're going over extraction part 2. The purpose of this experiment was to separate an unknown compound, maybe containing an acid, a base, or a neutral component, and to identify the unknown compound. The chemicals used in this experiment were sodium sulfate, diethyl ether, and hydrochloric acid. The sodium sulfate was used as a drying agent in the experiment. The diethyl ether was used to dissolve the unknown compound, and the hydrochloric acid was used to acidify and react with molecules and create separation from ether because of the density. And here's a chart of the physical properties of the chemicals we are about to use. The diethyl ether has a boiling point of 34.6 degrees Celsius, a molecular weight of 74.12 grams per mole, and a density of 713.4 kilograms per meter cubed, and a melting point of negative 116.3 degrees Celsius. The hydrochloric acid has a boiling point of 81.5 degrees Celsius to 100 degrees Celsius, a molecular weight of 34.46 grams per mole, a density of 0.825 grams per milliliter, and a melting point of negative 114.2 degrees Celsius. The sodium sulfate has a boiling point of 1.429 degrees Celsius, a molecular weight of 142.04 grams per moles, a density of 2.66 grams per centimeter cubed, and a melting point of 884 degrees Celsius. Safety. Diethyl ether may cause irritation to skin, eyes, and respiratory. If in contact, flush with cold running water. Diethyl ether is also volatile, which means that it evaporates, so this must be kept under the fume hood. Hydrochloric acid may cause serious irritation to skin, eyes, and respiratory. If made in contact, flush with copious amounts of cold running water. Disposal. The uncontaminated HCl was disposed inside the sink. The uncontaminated NaOH was also disposed inside the sink. The uncontaminated ether was disposed inside the non-halogenated waste container, as you can see right there. And the waste from the filters and the solution that we created were disposed in the halogenated waste container. Every other trash was disposed inside either the regular trash bin or the broken glass container. Here are a list of some of the materials that we use in this experiment. We have the stoppers, the centrifuge tubes, litmus paper, a Herschel funnel, a heat plate, as you can see right here, a 10 milliliter graduated cylinder right there in the corner, some beakers and pipettes, and a steam bath. Procedures. The first step in the procedures is the extraction of the basic component. First, the student dissolved the unknown compound in diethyl ether, then added HCl. The HCl reacted with the amine group attached to the carbon chain and formed ammonia and chlorine ions. Here's the equation for the HCl and ammonium. The solution then separates into two layers. This is due to the chemical density and diethyl ether's low polarity. Diethyl ether has a lower density than HCl, which moves it to the top of the centrifuge tube, and it is very low polar, so it doesn't mix well with HCl at all. The top layer contains the ether, neutral, and acidic component. The bottom layer contains the base component, the newly formed ammonia with HCl ions. The next step was to pipette out the lower solution and back extract it. Back extraction is simply adding ether to the bottom layer to make sure all the neutral and acidic components aren't left inside of it. The ether layer is then extracted by pipetting and put into the original top ether layer. The last step is to make the solution basic. The student added NaOH to the bottom layer. This created a water, a salt, and should have also formed a precipitate. But in this case, as you can see on the top right hand corner, right there is no precipitate. So it is safe to say that there was no basic component in the unknown compound. Part B. Extraction of the acidic component. First, the student added NaOH to the original top ether layer that contained the acidic and neutral component. The NaOH ionized to form hydroxide and sodium ions. The hydroxide takes a proton from the carboxylic acid and creates water, sodium ions, and a carboxylic group. The neutral and ether then separated from the NaOH and acidic compound. The two separated again because of the physical properties of diethyl ether. Now, in the top layer, you find ether and the neutral components, and in the bottom layer, you have the carboxylic group, water, and sodium ions. The next step the student took was to pipette the lower acidic component into a new centrifuge tube. He then back extracted the lower layer that was just pipetted out with diethyl ether. The last step was to acidify the lower layer with hydrochloric acid, which was supposed to form a precipitate. When the student added the acid, HCl, the hydrogens reacted with the carboxylic group and created a carboxylic acid, then forming a precipitate. The chlorine ions attached to the sodium ions and made then a salt. And as you can see in this experiment right here, the student did have a precipitate. So that means that it is safe to say that in the unknown compound, the student actually had an acidic compound. Part C. Extraction of neutral components. First, the student had to wash the neutral and ether layer with water. The student added H2O into the ether layer to make sure that the water molecules bonded to each other. The water molecules are less polar to the organic compound. That means that they would bond to the other water molecules because they were more polar. The next step was to dry ether from the water with a drying agent. The drying agent used was sodium sulfate, which absorbed all the water because it was polar. The next step was to separate the sodium sulfate from the neutral and ether solution. The student used pipettes filled with cotton to separate the sodium sulfate molecules from the ether and neutral components. This was difficult for the student because the filter got plugged up with the sodium sulfate. The last step was to remove ether solvent by steam bath. The student evaporated the ether basically by warming up the flask with water. When all of the ether was gone, all that was left was the solid neutral component, as you can see right here. Right there, solid neutral component after the steam bath. This was a good indication that we did have a neutral component in our unknown compound. Part D. Determining the unknown components through melting point. The student used a melting point apparatus to find the melting point of the components found from the unknown compound. As you can see on the right over here, we have a melting point apparatus with the thermometer, and inside here is our components. The acidic component had a melting point of 106 degrees Celsius. The neutral component had a melting point of 95 to 99 degrees Celsius. Results. We received only an acidic and neutral component in the unknown sample. Here is the neutral that we found, and here is the acidic component that we found in our unknown substance. The acidic component had a mass of 0.089 grams. The neutral component had a mass of 0.0842 grams. The acidic melting point was from 101 degrees Celsius to 106 degrees Celsius. The neutral melting point temperature was 95 degrees Celsius to 99 degrees Celsius. In conclusion, these two temperatures made the student believe that he had O2-oleic acid as the acidic compound and benzyl for the neutral component. But the neutral component was actually wrong. The actual neutral component was the natrium at 101 degrees Celsius. The reason why the temperature was wrong was due to technique. During the separation process of the sodium sulfate, it was possible that some of this drying agent had contaminated the neutral component. This would affect the melting point and possibly throw off the neutral's melting point, which made the student believe that he had benzyl instead of phenatrine. Well, thank you for watching Extraction Part 2. I'm Daryl and you have a nice day.